Assalamualaikum warahmatullahi wabarakatuh. Okay, today we want to learn in topic 1. Okay, so just for review that our hydraulic we have 6 chapter. Okay, so introduction to open channel flow for topic 1, uniform flow in open channel topic 2, specific energy and control section in topic 3, non-uniform flow in open channel for topic 4, hydraulic structure and hydraulic machineries in topic 5 and topic 6. Okay, so for today, chapter 1 for topic 1 is flow in open channel. Okay, so we look at the end of this chapter, students should be able to define and explain on types and state of flow. Okay, identify types of open channel, define open channel geometries. Okay, so look at the open channel flow is flow of a liquid in a conduit with a free surface subjected to atmospheric pressure. So this is the open channel. Okay, sketch of open channel geometry. Okay, so example, flow of water in river, canal, partially full sewers and drains, and flow of water over land. Okay, so this is types of example of the smart tunnel. So this is example of channel, open channel. Okay, and also Tahan River Rapid, this is a natural channel. Okay, and also the Siberian Mandarin River, okay, in Siberian. Okay, this is a natural channel. Okay, the comparison between pipe flow and open channel flow, we have 5. Okay, the comparison between pipe flow and open channel flow. Okay, pipe flow, so the fluid completely fills pipe cross sections and no free surface. Open channel, we have exposed to atmosphere. Okay, fluid flows under pressure. Okay, and the open channel flow, slope influence using the gravitational force. Okay, gravity. Okay, so hydraulic grade line does not coincide with water surface, and hydraulic grade line coincide with water surface. Okay, this is not coincide with water surface for pipe flow. For open channel flow is coincide with water surface. Okay, so maximum velocity occurs at center of pipe flow for pipe flow. So maximum velocity occurs a little distance below water surface in open channel flow. Okay, velocity distribution is symmetrical about pipe axis, and open channel flow velocity distribution depends on channel roughness. Okay, so this is the difference between pipe flow and open channel. Okay, if in your final or in test you ask you to list some difference between pipe flow and open channel flow, so you can list this theory. Okay, so you can also sketch the figure. Okay, comparison between pipe flow and open channel flow. Okay, so we look at the practical application for open channel flow, hydraulic. Okay, flow depths in rivers, canal, and other conveyance conduits. Okay, apply in change in flow depth due to channel control, as example as weirs, spillway, and gates. Okay, this is called weirs, spillway, and gate is called hydraulic machineries. Okay, hydraulic structure. Okay, change in river stage during floods. Okay, surface runoff from rainfall over land, and optimal channel design, and others. Okay, so flow parameters and geometric elements. So we learn that depth of flow is y. Okay, normal depth is d. Okay, y is the vertical measure of water depth. So this is called from the free surface or water depth to the bottom slope here. Okay, so we get the y. Okay, for most applications, d is equal to y when theta is less than 10%. So like with a cos 1 degrees is 0.9998. So this is as the same one. Okay, so flow or discharge Q is the volume of fluid passing across section perpendicular to the direction of flow per unit time. Okay, so we use the Q of V is equal to Q over A. So we can use that Q is equal to AV. Okay. So this is the equation that we use in to get the velocity. Okay. T is the top width. Okay, top width. B is the bottom width. P is the weighted parameter and Y is flow depth. Okay, weighted parameter, we can highlight that the length of the weighted parameter is this one that highlight with the yellow here. So this is the weighted parameter length. Okay. So weighted parameter P is the length of channel parameter that is weighted or covered by flowing water. Okay, that I highlight with the yellow. Okay, the color of yellow here. So A is the cross-sectional area covered by flowing water. Okay, hydraulic radius R is the ratio of the flow area A to weighted parameter. So R is equal to A over P. Okay, R is A over P. Okay, hydraulic depth is the average depth of a regular cross section is D is equal to A over T. Okay, so this is the geometry of channel. Okay, using the trapezoidal. Okay, so this is an example that JKR used to design the standard surface drain. So we use the drain here using the trapezoidal. Okay, that I highlight with the yellow here. The types of the channel drain is using the trapezoidal channel types. Okay, so this one is using the triangular. Okay, the triangular. This is in the trapezoidal and this is triangular. Okay, surface drain standard JKR standard. Okay, so this is the types of open channel geometries that we use in rectangular, triangular, and trapezoidal. So this list of formula in this table is given in your test 1, test 2, and the final. Okay, so you use this formula, okay, to get the area, top weight, and the weighted parameter. Okay, so look at the activity 1. Okay, to find this is using the trapezoidal channel. So we want to determine the T flow area A with the parameter P and the hydraulic radius R. Okay, to find here and use the Q is to determine the state of flow. So the state of flow, I will explain in the last slide. Okay, the state of flow using the Froude number and also the Reynolds number, okay, to the state of the flow. Okay, now we look at the calculation to get the T, A, and P. Okay, so first you must find the Z. Okay, the Z is the Z, we look at the Z here. Okay, the Z is from this one. Okay, the Z is the value at this stage to get the Z here. Okay, the Z here. Okay, okay. So like to get the Z here. Okay, we know that the one is equal to this one 2 meter, but we don't know the value of the Z. So that's why we use this angle here. Okay, that's why you get the Z is 1 over tangent 60 degrees. So you get the 0.5774. So after you get this one, so you just put the Z to this formula to get the T. B plus 2 times by Z times by Y. Okay, Y we know that 2 meter and the Z here. So we get the T is this one. Okay, so after you get this one T, so you just use the formula of area, so you get the area. Okay, just put all the value here, so you get the area. And lastly, you find the weighted parameter and also the hydraulic radius. So just use the parameter equation parameter for trapezoidal. So you use this one and put all the value, you get the P here. And after you get the A and P, so you get the R is equal to over AP and you get the R is this one. Okay, So this stage we have learned is in state of flow. We learn it the last, okay, the last slide. Okay, so I will explain it after that. So we just look at the activity 1.2. Okay, so activity 1.2, find the flow area, weighted parameter P, and hydraulic radius. Okay, so area, so we can divide the area of this channel. This is the combination, okay, between the triangular, rectangular, and trapezoidal. Okay, so we can divide to 4 types of channel. Okay, combination of 4 channel. Okay, so A1, A2, A3, and also A4. And also we, if you don't, you can add also the area, just add area of 5 here. Okay, okay, so this is the total up for the A. Okay, so we look at the area here. Flow area of Z1 is 1 and Z5 is 1. So this is actually just change area for channel area of 5. This is change for area of, okay. This is the, because 1 is just the half of the triangular, so we get this one. So this is 1. Okay, A1, this is A5. A5 we use the area of the triangular. Okay, the A2 is the rectangular, A3 is also the rectangular, and A4 is also rectangular, and A1 is the triangular. So just put all the value here, so you get the area. Okay, the value of area. Okay, the weighted parameter, so you look at the weighted parameter is for that I highlight with the red. Okay, with the red highlight is the that I sorry, so highlight with the color, red color here. So this is the length of the weighted parameter that you must calculate. Okay, the length. Okay, okay, this is the length that you must to calculate to get the weighted parameter. Okay, actually this is the P1, P3, P4, and P5. Okay, actually this is P2. This is 2 is using the P5. Okay, just change the, this one is the P5. Okay, parameter at P5, and this is parameter 1. Okay, just change here. So just put all the value here and you get the P is this one. Okay, after you get the A and the P, so you get the R. Okay, that's all. Okay, this is the step to get the area, to get the weighted parameter and the R, using the combination of 3 or 2 types of open channel. Okay, so maybe in your test we use the single types of channel. Maybe we use just only the rectangular, sorry, trapezoidal. Okay, maybe we use the combination of trapezoidal and also the triangular, so maybe we use this combination. Okay, so maybe, okay, so maybe we use the combination here. And also we use the combination of the trapezoidal and also the semicircular. Okay, so it depends on the question. Okay, in your test or in your final. Okay, maybe we use the single type of open channel. Maybe we can combine between 2 types of channel. Okay, maybe we just 2 types of channel and also combine 3 type of channel. Okay, it depends on your question. Okay, so that's also we just look at the types of open channel. Okay, open channel can explain in more in prismatic and non-prismatic channel. Okay, prismatic channel is the channel which cross-sectional shape, size, and bottom slope are constant. Most of the man-made artificial channels are prismatic channel over long stretch. Okay, example of man-made channels are irrigation, canal, flume, drainage ditch. roadside, gutter, drop, chute, covered, and tunnel. Okay, so this is prismatic channel. Okay, all natural channel are having varying cross section and therefore are non-prismatic here. Okay, example of natural channel are tiny hillside rivulets through brooks, stream, river, and tidal estuaries. Okay, so look at the rigid and mobile boundary channel. Rigid channel are channel with boundaries that is not deformable. Okay, channel geometry and roughness are constant over time. Okay, so this is for rigid. For the mobile boundary channels are channel with boundaries that undergo deformation due to the continuous process of erosion and deposition due to the flow. Okay, examples are unlike man-made channel and natural channel. Okay, but for example, for the rigid channel are line channel, sewers, and non-erodible unlined channel. Canal. Okay, so canal is usually a long and marked slope channel built in the ground, okay, which may be unlined or lined with stone, measuring, concrete, cement, wood, or bituminous material. So this is in Kedah, Terusan Wan Saman. Okay, in Russia is Griboidov Canal. Okay. So flume is the channel of wood, metal, concrete or masonry, usually support on or above the surface of the ground to carry water across a depression. So this is the example of flume. Okay, to generate electricity. Okay, and hydroelectric. Okay, this is the open channel flume in laboratory. So we use it in our laboratory. Okay, here is a channel having steep slopes. Okay, natural chute falls on the left and man-made chute on the right on the Quebec. Okay, so this is waterfall in Quebec. Okay, so drop is similar to chute, but the change in elevation is within a short distance. So this is okay. This is the dam that have the drop here. Okay, actually the basin drop structure is designed to dissipate energy. Okay, so this is called drop. Okay, stormwater sewer is a drain or drain system designed to drain excess rain from paved street, parking lot, sidewalk, and roof. Okay, so this is called storm drain receive urban runoff. Okay, so it's called gutter. Okay, parking lot and access the rain. Okay, so type of classification of open channel flow, we have steady flow and unsteady flow, and also uniform flow and non-uniform flow. So non-uniform flow, we learn the rapidly varied flow and gradually varied flow in chapter 4 until to chapter 6. So uniform flow, we learn it in topic 1 until to topic 3. Okay, that's also the difference between the steady flow and unsteady flow, and uniform flow and non-uniform flow. Okay, so open channel flow condition can be characterized with respect to space. Okay, space uniform or non-uniform flow. Okay, and time steady or unsteady flow. So space, how do the flow condition change along the ridge of an open channel system? Well, we look at the uniform flow. So depth of flow is the same at every section of the flow dy dx. Okay, this is the respect to space. Okay, dy over dx. Okay, now uniform flow, depth of flow varies along the flow, dy over dx is equal to 0. Okay, so this you can sketch the figure to explain the uniform flow. So the depth of flow is the same at every section along the channel. Okay, the constant. So depth of flow varies at different section along the channel here. So this is non-uniform flow. Okay, so times, how do the flow condition change over time? So actually is using the dy over dt. Okay, so the steady flow, depth of flow does not change during the time interval under consideration, dy over dt is 0. Okay, unsteady flow, so the flow change with time, dy over dt is equal to 0. Okay, just for remember that space, you must know that uniform flow and non-uniform flow. Okay, but for the time, steady flow and unsteady flow. Okay, so this is, you can also sketch the to explain about the steady flow. Okay, the depth of flow is the same at every time. Okay, but unsteady flow is not same. Okay, not same from time to time. So the depth of flow change from time to time. okay, between the steady flow and unsteady flow. Okay, the flow is rapidly varied if the depth changes abruptly over a comparatively short distance. So this is called RVF, rapidly varied flow. Okay, example of RVF is hydraulic jump, hydraulic drop, flow over weir, and flow under a sluice gate. So this is we learn it hydraulic jump, hydraulic drop, flow over weir, and flow under a sluice gate in chapter 4. Okay, gradually varied flow. Example is flow over a mild slope and the backing up of the flow backward. So we learn it in chapter 4 until to chapter 6. Okay, so these two types of flow, rapidly varied flow and gradually varied flow, we learn it in chapter 4 until to chapter 6. Okay, so this is just sketch for the RVF and GVF. Okay, so this is state of flow. Okay, back to the activity of 1.1, that state of flow. So we use this using the Reynolds number and the Froude number. Okay, Reynolds number is effects by viscosity. Okay, so it depends on the effect of viscosity. So it can state as laminar, turbulent, or transitional flow. Okay, using the Reynolds number. Reynolds number is equal to velocity times by hydraulic radius divided by viscosity. So we use effect of viscosity, use the Reynolds number. Okay, so we can expand the state of this flow is as a laminar when the Reynolds number is less than 500. Okay, the transitional is between these, okay, types of flow. More than this one is flow is turbulent. So we use the Reynolds number. Okay, the flow is laminar when the viscous force are dominant relative to inertia. Okay, in laminar flow, water particles move in definitely smooth part. Okay, so if you expand the smooth part, also this is a laminar. Okay, the flow is turbulent if the inertial force are dominant than the viscous force. Okay, this is viscous force, this is relative to inertia. Okay, so the irregular parts is not smooth. Okay, this is turbulent. Okay, so effect of gravity. So we use the Froude number here. Okay, so we have learned the subcritical, critical, and supercritical. So this is using the Froude number. Okay, so in Froude number we use just state as the subcritical, supercritical, and critical. Okay, that's all. So regime of flow we can combine it with using the viscosity and gravity. So we can use as the subcritical laminar, supercritical laminar, or supercritical turbulent, or supercritical subcritical turbulent. So we use the state of regime of flow. So we can state the flow. Okay. So look back at the activity 1.1. So we can state the flow using the Reynolds number and also the okay, that's all. So we just finish our topic 1. Okay, that's all. Thank you. Assalamualaikum.